Hello everyone, you are welcome to today's class, and in today's class we are going to look at application of differentiation. So we are still on calculus, but we are going to look at application of calculus, specifically that of what differentiation. Okay, in one of our meetings, if you remember, we handled the first application. Okay, I didn't treat it strictly under the application of differentiation because I realized at the point that we knew how to differentiate a function. Okay, so I saw that it would be necessary for me to introduce you to that application, which basically had to do with differentiation, and that was finding the gradient of a curve at a point. Okay, so that one is treated, the first application is treated. Okay, in today's lesson, we'll be looking at the other application. The first one basically will be how to find equations of tangent and normal to curves. Okay, then we'll look at linear kinematics, okay, calculus application, differentiation application to that. Then after that, okay, if time allows, we'll look at how to find the turning point, okay, of curves. How to find the turning point of curves. So this will be the basic, okay, or our target, which will be the learning, okay, objectives for today's, okay, meeting. So like I said, so I'm going to skip, okay, the first application, which I said we've already dealt with that. That is finding the gradient of a curve at a point. Okay, you can see that we've done that. So those of you who are not privy to that, please go and watch one of the lessons. I think the last lesson on what on differentiation. Okay, we treated this one there. So that takes us to the second, okay, application. That is the application B, finding the equations of a tangent and normal to curves. A tangent and normal to curves. So closely linked to, okay, the first application, which had to do with the gradient, is what, okay, the tangent and equations. The tangent, okay, normal, okay, they are equations. Remember, if you are finding the tangent is a line, normal will also be a line. So if you are finding equation of a line, we will need a point and a gradient. Okay, and we know from where we are coming from, you know how to find the gradient. So it means if we are provided with that extra information, which is the point, we should be able to extract the equations of what the tangent as well as what the normal. Okay, so without much ado, let me more or less introduce you to that concept. So you know, if I'm dealing with my Cartesian plane, this will be my y-axis and this will be my x-axis. Okay, so now if I have a curve and I'm going to use, your curve could be quadratic, it could be cubic, it could be what have you, but I'm going to explain from the quadratic perspective. Even with the quadratic, I'm going to use that, okay, the one that smiles, okay, the one with the coefficient of the s squared being, okay, greater than 0, okay, being positive. Okay, so I'm going to, but it's by extension, any, or if you get the concept, any other curve, okay, you should be able to find, okay, the tangent. You know, we said the gradient of a curve, okay, at a particular point. Okay, so assuming if I want to find the gradient of what this curve at this point, oops, okay, so at this particular point, okay, what are we going to do? We need to find dy dx. So we know that the gradient m of any curve at a particular point will be given by dy dx, okay, your gradient function evaluated at the x value. So that's why I wrote at x is equal to a, evaluated at a. But if it is an implicit function, then you have to evaluate it at both x and what and y. So you have to fix in the x coordinate and the y coordinate. I said that in that particular lesson that I initially, okay, referred to. Okay, so now you know anywhere here, I mean point here on the curve. Okay, there's a curve, so the gradient will vary just as I told you in that particular lesson. However, if I want to get a tangent is any line that will meet your curve at let me say at exactly one point. Okay, so if I'm looking at this particular curve, okay, my only line that will meet this curve at exactly 1 point, that line is going to be horizontal. So maybe let me put it this way. This is my tangent. Looking at where my point is, this is going to be my tangent. Okay, so a tangent is a line that meets, okay, your curve at exactly 1 point. Okay, so this indirectly is your tangent. Okay, it's not always, okay, what do you call it, horizontal? Please take note. Okay, but it's because of where I have put my tangent, that is why. So it could be here, but make sure that when you draw it, okay, it will touch the curve at exactly 1 point. Okay, so tangent, this is your tangent. However, you know a normal is any line that meets the tangent at an angle of 90. So I'm going to draw a normal through, okay, this particular point, okay, where the tangent meets the line, the curve, I should say. Okay, so it's not looking like, so this will be my normal. So these two are, okay, lines. However, the normal is supposed to meet the tangent at an angle of 90, so it's perpendicular. Okay, so this is it. A tangent is a line, a normal is a line, just as I have said. Okay, so if you want to find the equation of a line, we know the equation of any line is given by y is equal to, did I say y? The formula, forgive me. Okay, so let me go back. All right. Okay, I've started exhibiting symptoms early. Forgive me. So we will have the equation will be given by y. We always usually use what? The point slope form. So y minus y sub 1 is equal to m into what? X minus x sub 1. So that if I know the gradient and I know the point on the line, I'm able to extract its equation. However, okay, if you look at where we are coming from, if you are asked to find the gradient of what? Of this curve at this point, then we know that the gradient m will be given by, just as I've stated over there, dy, okay, dx. Okay, so let me equally state that this is my curve is y and it's also equal to f of x. So in this case, my gradient function will either be dy dx or f prime of x evaluated at the x value, okay, of the point. So now this is what we are going to have. If you have the gradient of the curve, okay, at this point to be dy dx, and you should know that this point that you have there, the gradient of what? Of the curve at this point will always coincide, will be the same as the gradient of the tangent at the point. Take note, and I'm repeating, the gradient of the curve at this point is the same as the gradient of what? The tangent at, okay, to the curve at that point. Okay, so it means indirectly I know the gradient of what? Of the tangent. And we also know the relationship between that of what? Of the tangent and the normal. We know that the normal is perpendicular to the tangent. So it means the normal's gradient will be negative reciprocal of the tangent what? Gradient. So that's how come we have, okay, the formula here for the equations of what? The tangent and that of what? The normal. So the equation of a tangent to a curve will be given by y minus y1 is equal to m into x minus x sub 1. Remember the same equation. So in this case, your m here will be your dy dx evaluated at the x value. That's the gradient of the curve at that point. Okay, once you know your m, you know the equation of the normal, because the normal, its connection with the gradient of the tangent is that the normal's gradient will be negative reciprocal of the tangent gradient. So it means its equation will be given by y minus y1 is equal to minus 1 over m, okay, then into x minus x sub 1. Is my point well made, my professors? Is my point well made? Hello, are you there? My professors, are you there? Is my point well made? Or you are not responding? Can you hear me? Is my point well made for me to move on?
Yes.
Okay, all right. So now let's move on to, okay, worked words examples. Okay, let's see how best we can make use of this. Okay, so you can see that in finding the gradient, we will need the derivative, the first derivative. So if you don't know how to differentiate what functions, you wouldn't be able to find the gradient and therefore find the equations of the normal and that of what of the tangent. So please take note. All right. So in this case, this is what we are going to do. Okay, so as usual, when you read questions, we underline the salient part. We are asked to find the equations of what tangent and normal, so 2 in 1. Okay, of the following points are the given, okay, the following curves are the given point. So let's look at the first one. Okay, so solution, major question number 1. Okay, then you come to minor question A. Oops. Okay, so please give me some few seconds. Let me deal with what? That unfortunate situation that we have there. My digital board has become very sensitive. Okay, so let me see if, oops, okay, so it means I have to, okay, pause then, do the needful, forgive me. All right, so let me pause then, rectify that quickly. Okay, so having dealt with that, I was saying that you write your major question number, okay, then your A, which is the minor question number. A, what are you giving? Y is equal to your curve is 1 over 3, okay, x cubed. Okay, then minus what? X squared. Okay, minus 24x. Okay, then plus 5. And what are you giving? The point that you are giving is what? 0. Okay, 0. That's the origin. Okay, so you are finding the equations, okay, of the tangent and normal. So finding 2 equations, okay, to this particular curve at that particular point, 0, 0. So now this is what we do. Okay. Usually, you know, this one entails a formula, and like I always advise, quote the formula and let the formula guide you, okay, as to how you are supposed to proceed. Okay, but in this case, you know, for experience or by experience, okay, that anytime you are finding equation of what, of a tangent, of a normal, of a line, you need a gradient. Okay, so I am equally going to follow suit. Okay, I will quote the formula and let the formula what guide me. So I'm going to write, first of all, I want to determine the equation of the tangent. So I'll write equation, maybe later I'll refine it, okay, of tangent. We know will be given by, okay, let me calm down because it won't go there. Y minus y1 sub 1 is equal to m into what? X minus x sub 1. Is that clear, my professors? So having quoted the formula, I know that in this formula, I will need my m, and I will need my x sub 1, y sub 1, which will be a point on the tangent, and that is where, okay, it's the same as the point that your is on the curve. Okay, the point that your tangent passes through is the point on the curve, which is what we are given here. So we know x sub 1, y sub 1. What we are left to find in this formula, the parameter that we need to find is the gradient. So now you go and write but. Okay, so you are going to find the gradient. Okay, my gradient m is equal to what? dy what? dx. Is my point well made? My professors, are you following? Point well made. Please, okay, respond for me to know that if my network is stable, then I know because you responded in real time.
Yes.
Okay, so now I need to go and find my dy dx. So dy dx, I know my y function. So we are experts in differentiation now. Differentiation, what do you do? Bring down, okay, then reduce the exponent by 1. So it will be 3 over, so 3 over 3, which the 3 will go. Then you write your x and reduce the exponent by 1. So it will be x squared then minus, bring the 2 down, x reduce the exponent by 1. It will be 1. You don't write it, then minus what? 24. Do you agree? Okay, so this is the general gradient. However, we are looking for a particular gradient on the line. So we have to come and write at, okay, x is equal to 0. So we are evaluating the gradient, okay, at that x coordinate for us to get a particular gradient. So this is the general gradient, okay, along the curve or on the curve. But if you want to find a particular gradient, okay, so at x is equal to 0, comma, your dy dx, which is your m, is equal to 0, okay, squared minus 2 into 0, okay, then minus 24, which in effect will give us what? Minus 24. Is my point well made, my professors? Okay, so it means we know our m. So I can say that indirectly, this implies that, okay, m is equal to what? Minus 24. Okay, so once you know your m, you are good to go. You can find the equation of the tangent and that of what? Of the normal. So I'm finding the equation of the tangent. So I'll write, therefore, okay, equation, okay, will be, so equation will be y minus y1 is 0, is equal to m, which is minus 24. Okay, into x minus x1, which is also what, 0. So in effect, we are going to get, okay, so we get y, let's go, is equal to what? Minus 24x. Do you agree? But remember, when we're doing coordinate geometry, I told you that anytime you are asked to find the equation of a line, unless otherwise stated, okay, leave it in the standard form. That is everything on one side equated to 0, making sure that your leading term, which is the term in x, is positive. So it means here I have to, the term in x will be negative if I move this one to the side. So it's better I move it to this side. So that will give me 24 x minus, so it will be plus y, okay, is equal to 0. So this will be the equation of what? Of the tangent. Remember, therefore is here. So we need to find the equation of the normal too. So in this case, I'll come and write equation of normal, or you can write and equation of normal. Okay, equation of what? The normal. You know the formula. Okay, with this one too, it won't go there, but I believe for you, you will have space, so you are supposed to continue. So let me even squeeze it there. Okay, but I will make sure it will still be readable. Okay, y sub 1 is equal to minus 1 over m into x minus x sub 1. Oops. Okay. Okay, so let me see if I can, okay, deal with it in a way. Okay, so after all, it didn't help. I couldn't. Okay, so I will calm down. My professors, I hope you are with me. Okay, so again, here you have only 1 point. So you just go and substitute. So, all right, this implies that you know your m, you know your x sub 1, y sub 1. So y minus 0 is equal to minus 1 over your m is minus 24 into x minus x sub 1, which is 0. Okay, so what do we have? Here we are going to get y to be equal to, this will cancel. Okay, so you have positive. So you are going to get what? X over 24. My professors, are you with me? So that gives us, you cross multiply, that gives us 24. Okay, y is equal to x. But remember, you need to leave your equation in that form. Okay, in the form ax plus by plus c is equal to 0. Okay, the standard form. So here x term is positive, so I have to move this one to the side. So I write therefore x minus 24 y is equal to 0. So this becomes the equation of the normal. Afa, my professors, is my point well made, my professors? Okay, so going forward, I will refine my presentation just a little. Okay, just a little. Okay, so Any questions at this point? Is everyone following? This is the first example, so please make sure you follow. Okay, if you are not following, let me know. Otherwise, as we move on, the questions become more technical and technical. All right, okay, so now, if that's the case, if you are fine, we can move on to, okay, the B. So let's go and look at what? Okay, yes, let's look at B. Okay, then I won't do all. And I will guide you along the line. I mean, for some of them, I will tell you what to do, then you will do that just for us to cover more. Okay, so now B. Okay, what are we given? We are given y is equal to what? X squared plus what? 4x minus 3 all over. So this is our curve, all over x. Okay, then we are supposed to find, okay, the equations at which point 1, what 4. So you've been given this, okay, point. All right, so let's look at this carefully. So here we know that we need to find the equation of what? Of two lines, one being normal and the other one being tangent. Okay, so we know that for lines, we will need the gradient. So here, I am going to find the gradient first. I won't quote the formula. So per experience, I know that I will need the gradient. And if I will need the gradient, okay, I will by all means, okay, have to differentiate my function. But if I look at this function, if I want to differentiate it in its raw form, I have to use the quotient rule. And remember, I advise you, okay, if possible, if you can avoid the product rule, okay, the quotient rule, okay, please do. So meaning, if you can change your given function to a situation where you'll be differentiating term by term, okay, it will be better. Okay, and here if you look at the denominator contains only one, okay, term in x. I mean only a monomial term, and it is in x. So it means you can, okay, avoid the quotient rule. So this function that we have here, we need to, okay, work on it before we can easily differentiate. So this will give us we'll write it term by term. So the partial fraction form of what you say to be x squared over x, that will give me x. Okay, then 4x over x, that will give me plus 4. Then I will get minus, okay, 3 over x. So that will give me minus 3 over x. But I know that if I'm differentiating term by term and I get to that particular term, which is minus 3 over x, I still have a denominator, okay, which contains a variable. So it means the quotient will be in play in that term. So what do? I can avoid. So that becomes minus 3x to the power negative 1. Is my point well made? My professors, is my point well made or I should come again? Should I come again or my point is well made? Oh, what is happening? Hello, are you there?
Yes, ma'am.
Okay, all right. So at this point, I will need my gradient function. So I'll write m, which is the gradient because I will need m, is equal to dy dx. And it will be dy dx evaluated at a certain s value because this was explicitly in terms of y. So that would be equal to dy dx will be, it will be d dx of this. So we are going to differentiate that. That will give us 1. Okay, this will go. It will give us 0. Then this will come down and give us plus, okay, 3 into x to the power negative 2. Is that clear? Hello, is my point well made? Okay, and for evaluation purposes, okay, we will want to bring the x to the power, the negative power down. So it will be 1 plus 3 over s squared. Okay, so that you write at, okay, this depends on x. So that's the general gradient on the curve, along the curve. If you want a particular gradient, substitute the s coordinate of that point. So at x is equal to what? 1. Okay, we are going to get what? Your m to be equal to 1 plus, okay, 3 into, so 3 over 1 squared. Okay, or someone can also substitute here. So you will get 1 to the power negative, okay, 2, but you end up getting the same result. So this gives us what? This implies that my m will be equal to 1 plus 3. So that will give me 4. Is my point well made? Hello, my professor, is my point well made? Okay, so I can come and write, therefore, equation of tangent. Okay, I know, oh, sorry, equation of tangent. I have to be, if I just write equation, if I was asked to find only one of them, then I can just write equation so that I know that it's referring to that line. But here I have to, so I need to distinguish between them. So tangent, oops, I've already written the tan. Okay, so tangent. Okay, and we know that will be given by y minus y1 is equal to what? M into x minus x sub 1. So this implies that I even have therefore there, so I won't use the implication. I'll keep on substituting below so that the therefore will simply be understood to be there. We are just being smart. Okay, so I will get y minus y1. Your y1 here is 4. That's your y coordinate here. Then is equal to m. We had 4 also for m. Okay, then into x minus x1. x1 is 1. Okay, so in effect, we are going to get y minus 4 is equal to 4x, okay, minus 4. Okay, so you have minus 4 here, so that will go. Okay, so in effect, we are going to get, so if you just move everything to one side, equate it to 0, but use the s term to do your movement. S term here is positive, so it means I have to move these two terms here. Okay, but in my mind, I'm moving the two terms there. So I will have, okay, 4x. Okay, then the minus 4, so it will be minus y. This will be plus 4, so it's equal to what? 0. This becomes the equation of the normal, of the tangent. And, okay, equation of normal. I didn't write is equal to, I wrote a column or semicolon. Okay, all right, so that will give me y minus y1 is equal to minus 1 over m into x minus x sub 1. So I am going to get, okay, therefore is already an end. So I can choose not to write it. This therefore is affecting the end that I'm doing here. So I can choose not to repeat it. So y minus y1, you know, is 4. Is equal to minus 1 over m. M is also 4. Okay, into x minus x1, which is 1. Is my point well made? My professors, are you following? Yes. Okay, so that in effect will give us, so here we will clear the fraction and expand at the same time. So if you clear the fraction, you multiply through by 4. So that gives us 4y minus 16 is equal to, the 4 will cancel this, so you get minus 1 times this. So it will give you minus x plus what? 1. So here your s term here is negative. So that means you need to move these two terms to the side. Okay, so my final equation for the normal will be x plus 4y. Then this will come here to be minus 17. Okay, is equal to 0. Point well made, my professors. Hello, my professors, are you there? Is my point well made? Okay, so if you are fine, then okay, we are moving on to the next question. However, we won't do C. I'll only guide you. The C that you have there, or we should do C. Okay, will involve implicit function differentiation. No, did I say implicit? You use the power rule. Okay, forgive me. Okay, so let's do that one maybe as a way of revising, okay, and getting the technicalities in the differentiation demystified. Okay, so I'm still looking at question 1, and this time around it was C. Okay, then it means I have to create another, okay, because this was intended for one of the implicit functions that we have there. So what am I giving? Y is equal to, okay, I have 2x cubed, okay, minus 3x squared. And remember, I won't do everything for you, okay, just for us to cover more. At the point where I know you can be on your own, I will leave you. So I'm only guiding, okay, us. So 2, then 6. Okay, that is the point that we are giving. Okay, we know that once we are finding equations of what tangent and normal, we need the gradient. So I can write, okay, but my m, which is the gradient, will be equal to, or gradient m will be equal to dy dx. Okay, so which will be equal to, okay, I'm going to differentiate this function. My y is a function to a certain power, and I cannot easily expand. Okay, so in that case, it means, okay, I cannot avoid the power rule. Okay, so we are going to deal with what the power rule, okay, or composite function differentiation rule. So that one we said, bring the exponent, differentiate it as if you are doing the normal differentiation. Bring the exponent down, so the 6 will come down. Okay, then you have, keep your function 2x cubed minus 3x squared plus what, x. Reduce the exponents by 1. Okay, so that will give us 5. But that is not all. Times the differential of what you have in bracket. So that will give us what? If I differentiate, I will get more than a 10. So I'll put it in bracket, and that will give us, okay, 6, okay, x squared, then minus 6x, okay, then plus 1. So at this point, this will be your general gradient function, which you can't expand. If you can expand, you can only expand the first term and what? And the first factor, I should say, and the last factor. But this one, you cannot expand. And like I advise, if possible, do that. But here, we are not, if the question asks you specifically directly to differentiate, then that is what you do and conclude with that. Okay, multiply this and this, then come and put the whole of this to the power 5 in bracket. And when you are multiplying this and this too, you get 3 terms. So you put that one also in bracket. But here, this is only a means to an end. So at this point that I know I have differentiated, though it's not in this simplified or the normal form that I'm supposed to leave my answer, I'm not worried. I can carry out my substitution and simplify. I need a certain value. So I'll go and write at x is equal to, and what is your x? X is equal to 2. My m, so if you have space, comma, my m, which is the gradient, will be equal to, you come and substitute. So you substitute, then you simplify. And once you know your m, getting the equation of the tangent will be very easy, and that of what? The normal. Is my point well made? So wherever you see x here, you put 2 there, and now you simplify. So this will be a particular value to the power 5. Okay, and this will also give you a particular value, and you should be able to deal with it. Is my point well made, or you want us to continue? Hello, is my point well made, or we should continue? Hello, are you there? Please, at this point, I would, okay, suggest you all put your mic, okay, unmute your, so that you can answer directly. It's not that, so I want the class to be interactive, especially in the morning, so that, okay, you will not be tempted to go back to sleep. All right, so I will take your silence to mean that you are fine, because if you are not fine, you will definitely talk. Okay, so that will be it. And with this one too, we use the implicit function. Okay, so did I say, why am I using implicit? Because maybe this page was created for the implicit. Okay, so this one is supposed to be, okay, 6 minus 5 all to the power minus what? Half. And if you are differentiating, you cannot expand 6x minus 5 all to the power minus half easily and get all the terms. So what do? You use the composite, okay, function differentiation or the power rule. Bring the power down, which will be minus half. Keep your 6x minus 5. Reduce the power by 1. So it will be minus half, okay, minus 1. So that will give you minus 3, on 2, that is minus 1.5. Then that is not all, time the differential of what you have here. So it will be times what? 6. If you differentiate what you have here, it will give you what? 6. So at that point, you are through with your differentiation. Go and substitute the x value, which will be negative 1, to get your m, the actual m. Then you put your two formulas, one each for the normal and the tangent, and you substitute your m, your x sub 1, y sub 1. Okay, so please take note. So on that note, I'm going to move on to, okay, we'll do F. Okay, once you are able to do F, you should be able to do the E. Okay, so now let's see the last question, okay, that we are going to do on the first set of questions will be, so let me create a page for it because a slide had been already used. Okay, so now that I have created, let's go and look at the F. Okay, so F. What are we giving? We are giving x squared plus y squared, okay, minus 2x, okay, plus y is equal to 6. Then the point minus 4 minus 1. Okay, so that is what we have. Okay, if you look at this function clearly, you can see that this function is not an explicit function. Y is not already made a subject, it's an implicit function. So it means if you want to get a gradient function, we have to, okay, what do you call it? Use the implicit function differentiation, okay, technique. Okay, so at this point, this is what we are going to do. So I'm going to write, I know, but I will need my m. M is equal to gradient dy what dx. Okay, so there's an implicit function. If I want to find dy, I want to find dy dx, then I have to operate, okay, d dx, the function on this. So I am going to get what d dx, okay, of what? X squared plus y squared. And please, you don't write dy dx, so it's d dx. Your y is this. Okay, indirectly is what you have is d dx, the operator. Once you are finding dy dx, the operator is what you have here. So it's the operator that you operate it on what? The function. So y should be equal to d dx of what? So it's like you are asked to find dy dx of this function, which we have gone beyond. Okay, so if you still have issues, go back and watch that lesson video. So if I'm differentiating this, okay, I will differentiate term by term. So d dx of x squared will give me 2x. d dx of y squared will give me 2y, okay, dy dx. My professors, are you following?
Yes, please.
Remember implicit function. Then if you differentiate, there's the x here, so it's the same. So your normal one will be 2. Then if you differentiate this with respect to, it will be d dx of y, and that will give me dy dx. So it will be plus dy what dx. And that should be equal to what? 0. Okay, so we are looking for dy dx. Okay, here. So now, how do I get my d? I collect the terms in dy dx on one side. So I have two terms, 2y dy dx. Okay, then plus dy dx. Okay, and that should be equal to, okay, with this one, this is positive, this is negative. If I move, this will be negative and this will be positive. So it's better I write the positive first. So I'll get 2 minus what? Okay, minus 2x. All correct, my professors. Hello, are you with me? At a point, immediately we get the gradient, I will ask you to go and continue. So here the challenge is what? The gradient. As for the equations of the normal and the tangent, okay, it's a formula work. Okay, so once you quote the formula, you substitute your gradient and then you are good to go. So at this point, what do we have? We are going to factor out your dy dx. So that will give us 2y plus 1 into what? Dy dx, or times dy dx will be equal to 2 minus 2x. So you write it again before you divide. So I'm assuming I have done that. So in that case, okay, you let me do that. Okay, so 2y plus 1 dy dx. Then it's equal to, I write it again, 2 minus 2x. Then I divide this one by 2y plus 1. Divide this one also by 2y plus 1. So in effect, I'm going to get dy dx to be equal to 2 minus what? Okay, 2x over 2y, okay, plus 1. Okay, and you can see that because here your function, okay, was an implicit function, it depended on x and y. Okay, when you are substituting, like I said earlier, I gave you the hint, I hinted earlier. Okay, I said you have to substitute your x and y. And when we were finding the gradients too, okay, in the first application that I said, the last differentiation, okay, that we did, or maybe the last but one lesson, okay, we handle a situation like that. So take note. So now at this point, what do we do? Okay, all that we need to do, like I said, substitute the x coordinates and the y coordinates, okay, at that point. So I can write at, okay, so here you can write at s is equal to this, y is equal, but I will write the point so that indirectly. So at what? The point minus 4, okay, minus 1. Okay, my dy dx will be equal to 2 into, so 2 minus 2 into what? X, which is minus 1. Okay, over 2 into y is what? Minus 4, then plus 1. So your dy dx so will be equal to, okay, the equal to here that I brought here, I know what something is equal to this. So whatever that I write here, the something must be equal to what I have there. So that will give me 2 plus 2. So that will give me 4. All over, okay, minus 8 plus 1. So that will give me minus 7. So in this case, I cannot conclude with my negative in the denominator. So it will give me minus, I bring it at 4 on 7. Okay, so this becomes what? My gradient. So indirectly, that is your m. So I can write, okay, I think at this point I could have done that, okay, for you to see that clearly, this is your m. So I would have written, this implies that my m that I'm looking for, okay, not therefore, you were not asked specifically to find m, so you cannot conclude with m after you have found it. So minus 4 on 7. So you quote the formula, okay, therefore, equation of what is given by, okay, then you go and substitute your m, okay, and the other one too, it will be in terms of m. Only the m will be in the denominator, and it will be, the numerator will be negative 1. You substitute, then the rest will be simplification. You take everything to one side, equate it to 0, making sure that the coefficient of the x term is what? Positive. Is my point well made, my professors? Hello, are we all fine? Okay, I asked you to unmute. Are you all fine?
Yes, please.
Okay,
Yes,
very good. So please unmute. The environment I can see is not noisy. So unmute so that you can respond in real time. Like, okay, so with this one too, maybe I will guide you, okay, so that we can cover, okay, more. All right, so let's see, find the equation of the tangent and normal to the following curves at the given points. Okay, so here at the point on the curve with the x coordinates being, okay, 2, so 5, you've been given the x coordinates. So after differentiating, it will be in terms of x, so you substitute, okay, the x coordinate. So it's similar to where we are coming from. Okay, and the function here is also pretty to differentiate. Okay, same as this one. At the point on the curve with the x coordinate, so when it means x is equal to 1, when you differentiate, your differential function will be in terms of what? Okay, yes, it will be in terms of x. You substitute, and that will give you the exact gradient. With this one too, you are giving the x, only that when you are going to differentiate this here, you can avoid the product rule. So you expand, then you differentiate term by term. So that will be how you get your gradient. And with this one, you know this is an implicit function. So if you differentiate this, okay, you find d dx of this is equal to d dx of that. An implicit function, we cannot give you only x value or y value to find a gradient, because the gradient likely will involve both x and what and y. So we have to provide okay the x and the what y coordinates of what that point before you can find the exact gradient in terms of a value. Okay, so you deal with this one. Okay, I think let's do the D, more of the implicit function, or let's do C, and let me see whether I duplicated this one. I didn't. So it means my expectation was to uh, just walk you through the solution. So at this point, I will maybe do it up to a point and guide you. So C, let's do C. Okay, what are we given? Y is equal to x into x squared minus 12. Then the point we are told x is equal to what? 3. So that's what we have there. So in this case, what do we have? I know I'm going to differentiate. So this function that I have there, if I want to differentiate, I have to, it's directly, I have to use the product rule. The product of x, okay, then x squared minus 12. But remember, you've been advised, if you can avoid the product rule, the quotient rule, the power rule, whatever rule, apart from the term by term or the sum and difference rule, okay, the rest avoid. So here I can expand, and that will give me x cubed minus 12x. So in this case, I have avoided the product rule. So I will differentiate term by term. So in this case, I will know that my m is equal to dy, okay, dx. Or someone can write, this implies that dy dx is equal to, after getting this, then your result, and you evaluate, but m is equal to dy. It's the same thing. Okay, so that will give us, this will be equal to dy dx. This is now your y. So that will give you d ds of the whole of this. So 3x squared minus what? 12. So at your point, okay, let me use, so at x is equal to 3, or if x is equal to 3, your m, which is your dy dx, will be equal to 3 into what? 3 squared minus what? 12. So whatever that you get, that will be your gradient. Go and put the formula for the equation of the tangent, substitute your m, and substitute, okay, in this case, when, let's see, okay, a vital information that I think I should have added that I ignored. Okay, so at this point, you can see that when you find the gradient and you are going to substitute, you, in terms of the formula for the tangents, y minus y1 is equal to okay, m into x minus xy. You found the m. Okay, take notes. And you've been given, okay, x sub 1, but you don't know y sub 1 directly, but indirectly you know. If you want to find the corresponding y coordinates, what do? Don't you substitute, okay, 3 into, okay, what you have there, the y, and that will give you the corresponding y coordinates. Okay, then you go and substitute that into the formula. Should I come again, or my point is well made? Is my point well made, my professors?
Yes, please.
Okay, so at this point, okay, let me finish this one. Maybe that's the first. So that will give you, deal with the power first. So it will be 3 into 9, okay, then minus 12. So that will give us 27, okay, minus 12. Okay, so that will give us 15. Am I right, my professors? Okay, but you know that if you go and substitute 15, so this is your x sub 1 and your m. If you go and substitute that into the formula, you'll be left with y sub 1. So I can also write at, okay, x is equal to 3. Okay, y will be equal to, come and substitute. Either you substitute it here into the original one or the expanded version. So I'm going to use the expanded version. So that will give me, okay, 3 cube, okay, minus 12 into 3. So indirectly, my y will be equal to 27, okay, minus 12 times 3, 36. Okay, so that gives your y to be equal to, my professors, let's go.
Negative
Negative 11,
9.
9. Okay, so negative 9. So that's what we have. Okay, so at this point, it means, okay, your point that you are looking for, the point given is rather 3 neg 9. So x sub 1, y sub 1. Substitute that one into, you are good to go. So as simple as that. Okay, with this one too, you differentiate the implicit function and you are good to go. Okay, the x, this one, both the x and the y given, and you need it. Okay, and this one too, I could have stated that, okay, no, even if I say at x is equal to -1, okay, if you substitute, it will be in terms, you wouldn't be able to find your y easily, okay, because of the square. So you won't get like terms to add and deal with it. So with this one, we have to provide you with both the x and the y coordinates. Okay, so now this is similar. Okay, I will only guide you. Find the equation of the tangent, okay, to point where it cuts the x-axis. So if it cuts the x-axis, then it means, if for nothing at all, that you know that the point that we are looking at, the s coordinate, if it cuts the x-axis, the y coordinate will be 0. So, okay, when y is equal to 0, find the corresponding x. So you can find the corresponding x to get the point. So it will be something 0. That will be your point. I hope you are with me. So here the point is not directly given, but you can find it from the given information. So where it cuts the x-axis, if it cuts the x-axis, at the x-axis y is equal to 0. Okay, so it means you know the y coordinate. Well, if y coordinate is 0, you can predict the x coordinate. Just go and substitute. So that will give you x coordinate. So it's like you've been given equation of this one, okay, the tangent and normal to this curve at the point, the y coordinate that you get was 0. Okay, all right. So, sorry, the x coordinate that you get there, then 0. So take note of that. Okay, so I think the rest you can proceed. And this one you have to expand to before you differentiate. Otherwise, you have to use the product rule. Okay, and this one too, at the point where it meets this line. So you have to find the point of intersection of this line and this line. Okay, before you can get that point that you are supposed to use. So point of intersection of a line. So this a line, this is a curve. So you substitute, okay, or usually will tell you to equate. Okay, at the point of intersection, the line and the curve will be the same. So just equate this and this. It will be an equation in x and solve for your x, and you are good to go. It's my point well made. My professors, are you following? Okay, so this one is also similar to what we have there. Okay, just read the question, you appreciate it, okay, and you move on. Gradient, okay, of P, so you know, and P is a point on the curve where x is equal to this. Okay, all right. So basically, an equation of the tangent at P. Okay, so I think and the normal, basically the same thing. Okay, so this one to basically only that is implicit. Okay, so you know how to deal with it. ddx of that side, you differentiate, you substitute. Implicit as well here. You should be able to deal with it. Okay, find the equation of the curve. Okay, hey, no. Hey, the question here is not complete. I will check and revert, okay, later. The equation of the curve, this is equal to 0. Okay, because this it lacks something. I. Okay, so the equation of the curve is okay. This determine the gradient of the curve at this point. So there is nothing wrong. Okay, so this is the equation of the curve. Find the gradient of the curve at this point. So you differentiate, then you substitute implicitly. Substitute the x coordinates, y coordinate. That will give you the gradient. And you are asked to find the equation of the normal, which will be given by y minus y1 is equal to -1 over m into x minus x1. So you use the m that you find here, okay, to find the equation of the normal. Okay, as simple as that. So there is nothing wrong with the question. Okay, so that will take us to our next, okay, application. So at this point, I would want to give you your water break. Okay, so you are welcome back from the water break. So let's look at the next application. I think this run rather should be, I'd wanted to effect that change. So let me quickly do that. Okay, so, okay, this should be C. Okay, the A was the gradient, B was the equation of the normal and tangent. So it means if I have to, because I repeated it all along, so I have to, Okay, change it. Okay, every all lines. So let me quickly do that. Okay, I think that is it here. So this will be probably be the last one. This is average velocity. No, acceleration is supposed to be the last one. Average acceleration. Okay, so I think we are good to go. So thanks for your patience. Oops. Okay, start from here. Displacement. So now back to what we are supposed to do. All right. So see, we are looking at the third application, which is linear kinematics. Linear kinematics basically, okay, has to do with okay linear motions. Okay, motion, okay, in a straight line, basically. Okay, all right. So quickly here we'll be dealing with displacement. Okay, and that will be the foundation, our foundation function, basically. So displacement refers to the change in position of an object. It is defined as the shortest distance between the object's initial position and its final position. So the starting point and the terminal point, okay, the difference, along with the direction, okay, of this shortest distance. Okay, so basically that's it. So there is a difference between distance and what and displacement. And I think when we were doing vectors, I mentioned that okay, displacement is a vector quantity, however, distance is a scalar quantity. Displacement will have a direction. Okay, so it's where you are starting, where you are ending. So that direction is what we are looking at. And okay, please take note, just briefly, if assuming I am at a point and I'm asked to move 5 units, or let me even say 5 kilometers east, 5 kilometers, okay, I need to move 5 meters east, okay, to the east. So assuming this is it, I move 5 meters. So this is supposed to be a straight line anyway. Okay, so 5 meters. I want you to see the exact distinction. Let me see if I can use this one to bring to bear the exact distinction between displacement and what distance. And you are asked to move, okay, 3 meters, okay, up north. So at this point, I move 3 meters up north. So maybe this is 3 meters. After that, you are asked to move 5 meters, okay, to the west. So 5 meters, okay, to the west, which will be a horizontal line. So you end here. So this is 5 meters. Okay, in terms of distance, it's going to give you 5 plus 3 plus 5, which will give us what? 13 meters. Is that clear? That's the total space, okay, covered. Okay, that would be your distance. But in terms of displacement, if I started from the point here, I was here, and I ended here, then I'm looking at the shortest distance between these 2 points, which will always be a straight line. Remember what we did in the format. So I'm looking at from A towards B. And you can see that if you look at it critically, because these two lines are parallel, this is also parallel to that. It means that the distance here will be 3 meters. And the 3 meters that you have here will be your displacement. Okay, so this displacement will be 3 meters. However, your distance that you moved, okay, you covered, okay, will be what? 13 what meters. Is my point well made? The explanation well understood? Professor, is the explanation well understood? Oh, okay, all right. You are still not responding. I've told you to, okay, unmute. Let me see those who have done that. Okay, please unmute so that you can respond. You don't have to unmute before you respond. Immediately I ask a question, you can respond straight away. Please unmute because I'm not finding it interesting asking you questions and you not responding. It's a class. I'm not lecturing. Even if I'm lecturing and I ask you questions, you have to respond. Okay, otherwise, the next time it happens, we'll end the class. Okay, because I'm teaching where students are. I'm not recording, okay, where students are not available. Okay, so once you are here, I need to hear your voice. Okay, thanks for your understanding. So let's move on, okay, to, okay, so I will continue to read. Okay, so consider a particle which is moving in a straight line such that its displacement from a fixed point is s meters. So displacement usually we denote that by s. It could be capital S or small s. Only that usually we use capital S, but you can use small s. S is s. Okay, at a time t seconds. So s is equal to f of t, meaning displacement will always be a function of t. So your displacement function is always a function of t. It depends on time. Okay, so that's the meaning that we have there. Now let's look at another concept that you need to know, okay, here under linear kinematics. Then, okay, all the concepts before we go and look at specific examples. Okay, so velocity, and we know the science students will have some, but the basic definition, okay, of a velocity, which usually we denote by v, is the rate of change of displacement with respect to time. And rate of change is differentiation. Anytime you are differentiating any quantity with respect to, so your differential factor, okay, or function, okay, is a rate of change function. So d dt is a rate of change function. So if you are finding rate of change of what displacement with respect to time, it means you are finding d dt of what your displacement function, which is s. Okay, and that will give us the s dt. So v is always equal to what the s dt. When you differentiate the displacement function, you get the velocity function. That is the meaning. Or, okay, f prime of t is equal to, that is f prime of t will be what? Your v. So if you differentiate your function, your displacement function, which is a function of t once, you get what? The velocity function. And you need to note this because at a point you'll be, the science students are preview to this, okay, but I have non-science students here as well, so please take note. If v, your velocity, is equal to 0, then this tells us that the particle, okay, is at rest. Okay, your particle is at rest, either at rest momentarily or finally at rest. Okay, so please take note. All right, then if v is less than 0, then it means the particle is moving in the opposite direction to which the displacement is measured. Please take note. In the opposite to the direction to which, okay, the displacement is measured. So opposite to the direction in which the displacement is measured. That's the only situation where your velocity will be what? Negative. Please take note. All right. Okay, so with that, we can move on to the acceleration. So acceleration, which is usually denoted by A, is the rate of change of velocity with respect to time. So if you differentiate velocity with respect to time, you get what? Your acceleration. So acceleration will be equal to dv dt. That is d dt of v. So that will give us dv dt. Or the displacement function is now differentiated twice. So it will be d squared s over dt squared. Remember, we did the higher order derivative, okay, when we're doing the differentiation. Or I have differentiated my function twice. So it will be f prime prime of what? Of t. So if you differentiate displacement, that's all that you need to know. You get velocity. If you know your velocity function and you differentiate, you get what? The acceleration. Okay, that's all. And you need to note this as well. If your A is 0, your acceleration will give you a particular value, which could be 0, it could be negative or positive. If it is 0, then it has a constant velocity. If it is greater than 0, then it means the particle is accelerating. If it is less than 0, then the particle is what? Decelerating or retarding. Please take note of these basic what concept. So now with this, we can move on to the average, okay, velocity. Okay, so average velocity, which is usually denoted by v sub average, or some of them use v sub a. Okay, you will define it. So however you define it, that is up to you. Usually we use v sub avg for average. So velocity average or average velocity. So if a particle at time t sub 1 travels a distance s sub 1 and at t sub 2, okay, a distance of s sub 2, where t sub 2 is greater than t sub 1, so your second time must always be greater than your first time. Then the average velocity of the particle within the time interval is given by, okay, so it will be your S sub 2 minus S sub 1 and your T sub 2 minus T sub 1. So you get your S sub 2 by substituting the T sub 2. And you get the S sub 1 by substituting the T sub 1 into the S, okay, function. As simple as that. So that's a change in S over change in T. Okay, the average, okay, velocity will be changing, okay, your displacement over change in what? In time. As simple as that. Is my point well made? Okay, so now the last one, that will be the average, okay, acceleration. So if a particle at t sub 1 has a velocity of v sub 1 and t sub 2 a velocity of v sub 2, okay, where t sub 2 is greater than t sub 1, then the average acceleration within the time interval is given by, okay, so that one would be A for average, sorry, for acceleration, then sub AVJ for average, and that would be equal to v sub 2 minus v sub 1 all over what? T sub 2 minus T sub 1. So in effect, indirectly, we are also trying to say that the average, okay, acceleration will be equal to, okay, the change in velocity, change in v over change in time. As simple as that. So average velocity is calculated in terms of changing, okay, your velocity with respect to time. Okay, that's a change in v over change in t. But an average velocity is done with respect towards the displacement. So change in displacement with respect to time. So indirectly, I'm not sure it's a change in displacement over change in time. Okay, it's different from change in displacement with respect to time. Okay, that is d dt. Please take note. This is change in displacement over change in time. Okay, the other one is just change in displacement with respect to time. It's different from change in displacement, okay, and change in time. Please take note, they are not the same. All right, so that will give us all the basic concept that we need to know. Now let's go and deal with, okay, the following questions. All right, so word example, and that is where I want to end. So assuming, so this is what we have. A body moves in a straight line so that its distance, at this point, I want the class to be very interactive. At a point, I'll be asking you certain questions based on natural situations. Okay, so a body moves in a straight line so that its distance from the point O after time t seconds is s meters, where s is, okay, what you have there. Okay, show that the body is at rest at two different times. Then find the acceleration of the body at these times and interpret your results. Okay, all right, so let's go and look at the solution together. So we read the question indirectly, we appreciate the demand of the question. So we are moving on to find the solution. The question is 2 in 1. The first part, okay, we need to find, okay, we need to show that the body is at rest at two different times. So we need to find 2 times that the bodies will be at rest. Then find that the second part of the question is to find the acceleration at the times that we found it. So it means if this first part of the question is wrong, automatically the second part will be wrong. And even with the second part, we have to, okay, it's 2 in 1. After finding the acceleration, we don't end there. We have to interpret our result. Okay, so quickly, let's go and look at it. Okay, we extract. So given, or you can choose not to write the given, by your S is equal to, your displacement function must be extracted, okay, or must be written. So 2t, okay, minus 3 on 2, okay, t squared, okay, then plus 1 on 3, okay, t cubed. Okay, so in this case, we are looking for, we said, show that the body will be at rest at 2 points. So when the body is at rest, we said that the velocity will be 0. Is that not it? So what will be the condition for a particle to be at rest when its velocity is 0? So you write at rest, okay, you know that v, which is the velocity, must be equal to 0. Okay, but your v, you know, is equal to ds dt. My professors, I hope you are with me.
Yes, please.
Okay, so we are going to find the SDT. So I will come here close to the margin and write instead of writing the equal to be in line. So we have our displacement function we can differentiate. So if you differentiate your displacement function here, okay, this is going to give us, okay, this to the power 1. So we get 2. Okay, let's do it together, the whole class. 2, the whole class, minus these 2 will come here. The whole class, let's, I told you that this time around, I want you to contribute. The 2 will come down, these 2 will cancel, so I'll get minus 3t. Am I right?
Yes, please.
Then the last term will be plus what?
2 on 3t squared.
Okay, the 3 will come down, so 3 will cancel, so you get t squared.
3t.
Is it clear now? So if you get this function wrong, you know you are doomed. Okay, all right. So now that I know my velocity function, I can say that you can see that obviously your velocity function is a function of t, which is quadratic, t squared. So it means it's a quadratic equation in t. Likely, if you solve, you get 2 t values, and that will give you the 2 distinct, okay, times that you have there. So in this case, I am going to write that this implies that because I've stated that my v should be equal to 0. So this implies that here I'm going to rearrange t squared minus 3t. Okay, so let me calm down. My t is looking like a power. In math, whatever that you write, you have to be careful. So if it's not, it's ambiguous, deal with it. So 3t, okay, then, okay, my plus 2 is equal to 0. So you are going to solve this. Thankfully, the leading term, okay, coefficient, its coefficient is what? 1. So we can factorize without grouping. Okay, so we indicate our 2 brackets, which will take our factors is equal to 0. So the 2 brackets, it will be t, then we go and look for the factor pair. That's what you attach. The factor pair of 2, okay, when you multiply, you get 2. When you add, you get minus 3. Will be minus 2 minus, okay, 1. Am I right? Professors, I hope you are with
Yes,
me.
please.
So you just come and attach these to factor pair. Then at this point, you set each of the factors to 0. So it will be t minus 2 is equal to 0. Okay, or t minus 1 is equal to 0. So by the 0 product rule, so t will be equal to 2 here, or t will be equal to what? 1 here. So we are supposed to show that the particle is at rest at, okay, 2 different times. So we've gotten 2 different times. So therefore, okay, so this will be, let's say, ts, okay, t, okay, so therefore, so well, that is 1 second, 2 seconds. So please take note. Okay, I've told you anytime you read question and you see show underline, you see prove underline. So you forgot to underline that. So therefore, the particle is at rest at 2 different times. Is that where we end? I've given you a vital information already. When you see show, how you are supposed to draw your conclusion. Something vital must be attached. Okay, as required, don't forget. Is that clear?
Yes, please.
Okay, you know I've told you this before. Okay, so make use of it. Okay. All right, so now we are done with what? Okay, what we have there. So in this case, you can, okay, continue to this. You can see that the second part is the same question. So you are not moving from a sub question to another sub question number. So you don't leave any spaces between your steps. So you continue. The second part, we need to find the acceleration at these times, okay, and interpret the results. So 2 in 1. Okay, so we need to find the acceleration. We don't know the acceleration function. Okay, so we cannot straight away find the particular acceleration. So before you can find particular acceleration, meaning the acceleration at the time that you have there, we need to know the acceleration function. Okay, so in this case, I will go and write, but I know that my A acceleration will be equal to what? dv, okay, dt. Do you agree? Now, professors, are you with me?
Yes, please.
Okay, so this implies that my A will be equal to dv dt. Okay, where is our vein function? And please take note, okay, you use this original vein function. Okay, sometimes if you form the equation, you can reduce the equation. So don't come and take the reduced form of your original function. Always use, that's the more reason why I took out was the vein and, I mean, yes, and found it. I could have formed the equation straight away. Okay, by writing, okay, this implies that I differentiate this that right equal to, but I took out the vein, okay, find the vein or found the vein before equating, so that when you want to fall on the vein function, you know the exact vein function. So the exact vein function is here. So if I differentiate that, I am going to get, okay, minus 3 plus 2t. Do you agree? My professors, are you with me? Okay,
Yes,
I would have straight away written it as 2t minus 3 because I know that my first term is negative, the second will be positive, and I've advised you to always write the positive term first. Okay, so if you fail to do that, okay, then maybe you have to come and write minus 3 plus 1. Sorry, did I write that one again? And in this case, you are not concluding with it. So even if you end here, you won't lose any marks because we are not going to write therefore A is equal to. You were asked to find the acceleration at these times, not the acceleration function. So you could have ended there. That's my point. And it will not be costly. Now, if we're asked to find the acceleration straight away or directly, then you have to always swap in your conclusion. So 2t minus. Okay, in that case, you write in brackets, you attach the units. Okay, all right. So now let's go and find. So at our first time, okay, t is equal to 2 seconds. We want to find a, comma, and always this will be too short to take a line. Don't come down. So a will be equal to 2 into 2, okay, minus what? Minus 3. Okay, so this implies that your a will be equal to 4 minus 3. Okay, so that will give us what? 1. So it will be 1 is acceleration, so meter per second squared. Am I right? Hello? Is my
yes,
point well made? Okay. Then
yes,
here we want to interpret our results. So we found it and we are going to interpret, okay, our results. Okay, so we will come to the interpretation. Let's see. Okay, the A is positive, and we said if A is positive, it means your particle is what? Let's go back and see, especially the 9 science students,
accelerating.
is accelerating. Okay, so, all right, so we'll come, okay, so let's draw. So in this case, I can say that, okay, hence, or therefore, okay, you are asked to find the acceleration at these times. So let me write, therefore, A, I need to draw my conclusion because I was asked directly to find that. A is equal to 1. I should have drawn my conclusion. I could have done that here. Meter per second squared. Okay, so hence, I'm interpreting the results. Hence, the particle, but once I've used therefore, I can't use therefore again. Hence, the particle, let me, was it a particle, a body? So you go by what you have in the question. So don't use, okay. So hence the body is accelerating. Okay, then we come to at, okay, t is equal to, our second time is what? 1 second. So t is equal to 1. We'll get A to be equal to 2 into 1 minus 3. So this implies that your A is equal to what? 2 minus 3, so minus 1. You were asked to find the A, so you conclude with it. Therefore, A is equal to minus 1. You attach your unit, meter per second squared. Okay. All right, so now you interpret. Hence, the particle is what? The body is what?
Decelerating.
Decelerating or retarding. Let me use retarding as for, okay, at that time. So at time t is equal to 1, the body is retarding. At time t is equal to 2, the body is what? Accelerating. As simple as that. Afa, my professors, are you with me?
Yes,
So
please.
here the key concept is if you differentiate the displacement function, you get the velocity function. Velocity function, if you differentiate, you get the acceleration function. That's all. All right. Okay. So let's go and look at our second question. Before we look at our second question, any questions? Any questions, my professors?
No question.
Okay, all right. So now let's go and look at, okay, our second question. So two, let's read the question. A particle moves so that if distance from the starting point O is given by, so that the displacement, okay, function. So given, okay, the displacement S, okay, to be equal to T cube, okay, plus 5T, okay, then plus 12, okay, plus 12. All right, so now what are we supposed to find? We are supposed to find the velocity when t is equal to s. When t is equal to 2 seconds, forgive me. So we need the velocity, the general velocity, before we can find the particular velocity. So the general velocity will be the velocity at what time t? Okay, seconds, and the particular velocity will be at a specific time. Okay, so in this case, we are going to find the velocity. So, but, okay, velocity v will be equal to ds dt. Okay, which will be equal to, okay, ds dt will give us 3t squared. Let's go. Plus what? My professors, are you there? Let's do it together. Plus, we are sharpening our differentiation skills. Oh, my professors, are
Plus
you there?
5.
+5.
Plus 5. Let's go. So now that will be your v function. So, but you are asked to find v at this is the general v. Okay, so at, okay, your first time, that is the t is equal to, so at the given time, t is equal to 2 seconds. At t is equal to 2, you can write that. Okay, your v will be equal to, so let's go. It will be 3 into 2 squared, okay, plus 5. Okay, so that implies that your v will be equal to, okay, 3 into 4 plus 5, okay, which will give us what? Okay, 12 plus 5, and that will give us what? 17. Am I right? But don't forget your unit. So it will be meter per
Yes,
second.
please.
Okay. Okay, let me, if I'm doing that, then it means I'm concluding. So I'll write therefore, it's my conclusion that I will attach the unit. I cannot fail. V will be equal to, or let me use velocity because I introduced the V. Okay, though universally is taking either velocity, okay, will be equal to 17 meter per second, or meters per second, I should say. Afa,
Mr. Hackman,
yes, please.
please, are you supposed to indicate that the velocity at t is equal to 2 in your conclusion?
No, no, you've already stated that one up here. So we know that we are finding the velocity at t is equal to 2. So when you conclude, don't go and write at t is equal to 2 because you've stated it up here. So we should know that you are finding the velocity at t is equal to 2. You get it? So give
Yes,
us the
please.
value of the velocity at t is equal to 2. So that value is what you conclude with. You don't attach anything here. Is that okay?
Yes, please.
All right, okay, great. So now let's go and look at the B. So you leave a space before, or did I normal? I didn't. So this is supposed to be A. So when I'm moving on to B, I would have known. I'll ask myself, have I written A that I'm going to do right B? If I have not, then I have to go and cure that. So then now we come to B. Okay. All right. B, we want to find the acceleration after 2 seconds. Okay. So it means we will need the acceleration function. So, okay. So in this case, I know that acceleration A will be equal to what? But, okay, you can choose not to write the button, only that I want to be consistent. Okay. It's like I'm quoting a formula. Anytime I quote a formula, usually I want to write but. So, but A is equal to, okay, dv dt. So it means if your velocity function is wrong, okay, the rest will be wrong. Okay, so A will be equal to, so let's go dv dt. Your velocity function is what we have here. So that will give you 60. Am I right? If you differentiate. Okay, so you cannot say that therefore A is equal to 60, whatever. The question didn't ask you to find the general acceleration, but particular. So you come and write at, okay, the t that you are looking for. So at after 2 seconds is the same as at t is equal to 2. Do you agree? Do you agree? Usually when we say after, okay, and at, okay, the two we use the same, okay, values, because between after and at, okay, some microseconds, so negligible. Is my point well made here? So if you say after 2 seconds, don't go and assume maybe it will be 3 seconds, it will be 4 seconds, what have you. Okay, it will be seconds, then some microseconds. Okay, so the difference isn't that significant. So it means you should still treat it as you evaluating it at that point. Okay, t is equal to 2. Is my point well made, my professors?
Yes, please.
Okay, all right. So now at t is equal to 2, your A will be equal to, so now let's go. Your A will be 6, okay, into 2. Okay, so that will be equal to what? Okay, 12. So in this case, therefore, okay, your acceleration will be equal to what? 12 meter per second squared. Alpha. So after this, the rest of the questions, you should be able to deal with it. Okay, so now we are left with C, which talks about the average, okay, velocity. So now let's see what we are going to do. Okay, so C, okay, but V average will be equal to, we know we said that will be the change in displacement over change in time. So it will be S sub 2 minus S sub 1 all over T sub 2 minus T sub 1. All correct. My professors, are you with me?
Yes, please.
Okay, so now it means we need to go and find, okay, T sub 2, T sub 1. T sub 2 is your second time. You remember we said T sub 2 must be greater than T sub 1. So it means this will be T sub 2, this will be T sub 1. Alpha. So we use this T sub 2, sorry, T sub 1, which is the 2 seconds, to find what? Your S sub what? 1. And use the T sub 2, which is the 4 seconds, to find what? Your S, okay, sub what? Sub 2. So let's go and do that. Okay, so in this case, okay, so you are going to write but, or, okay, let me write T sub 2, T sub 1 is equal to what? Okay, 2 seconds, so 2. And okay, T sub 2, okay, is equal to 4. Okay, if you want to. So at T sub 1, which is equal to 2, okay, your S sub 1 will be equal to, so you go and substitute this T sub 1 value into your S function. Okay, the value that you get will give you S sub 1. Afa, my professors,
Yes,
I hope you are following.
yes,
Okay, so let's go and do that together. So that will give us 2 cube, okay, here plus 5 into 2, then plus what? 12. Is that clear? So that will give us, this implies that your S sub 1 will be equal to 2 cube, which is 8, okay, plus 10, then plus what? 12. So this will give us what? 20, so 30. So that will be equal to 30. Usually I don't write more than 2 equal tos, so I will not. So that some of you, even when I don't write it, when I don't do it, you do it. So how much more? So I will write is equal to 30. I'll bring it down. Okay, then at, okay, t is equal to 4. Okay, we are going to get what? So seconds here. When you are substituting, that you can ignore. So that will give us S sub 2, and that will be equal to, let's go, 4 cube plus 5 into 4. My professors, I hope you are following. Then plus 12. Okay, so let's go. What would that give us? This implies that your S sub 2 will be equal to 4 cube.
64.
Okay, so 64 plus 20 plus 12. Okay, so that will give us which value?
96.
Okay, so 96. Okay, so we know all our parameters, T sub 1, T sub 2, S sub 1, S sub 2. So we are in a comfortable lead. We have to go and substitute. Okay, so at that point, I am going to write, therefore, my average velocity, which is V average, okay, will be equal to, we said S sub 2 minus S sub 1. S sub 2 gave us 96 minus S sub 1, which gave us 30, all over, okay, T sub 2, which is 4, minus T sub 1, which is 2. So that will give us, hey, let's go, 36 over 2, am I right?
Yes, please.
How can that be 36?
66.
66, all right, okay, so take note of that, all right. So it will rather be 66. Okay, so 66. Okay, so we are doing physics like that over 2. So which will give us what? 33. But don't forget your unit. It's velocity, so meter per second. All right, that's the average velocity. Okay, and the other one is average, okay, acceleration. So the D, you leave a space. Okay, but quote the formula. Okay, A sub AVG will be equal to, we said, that is the change in velocity over change in time. Okay, so it will be V sub 2 minus V sub 1 over, again, T sub 2 minus T sub 1. Afa, my professors. So we need to go and find V sub 2 and V sub 1. Let me see whether, I think we did that. Okay, we've done V sub 2. We've done V sub 1 at t is equal to 2 seconds. That's the first, because it's set to that. So you've done that one. So I'm going to write, already you've stated, okay, t, okay, here 2 is t sub 2. So your t sub 1 is equal to 2 seconds. Okay, you can even do that as a rough work. Okay, extract, so t sub 1 is equal to 2 seconds. T sub 2 is equal to what? 4 seconds as your rough work, so that straight away you come and write at this, then you move on. Okay, at T sub 1. Okay, so at T sub 1, which is equal to 2 seconds, okay, your V is equal to, don't go and calculate again because you've done that one in A, it's the same major question. So we go and infer. So let's see, what did we get? Okay, when T is equal to the V, give us 17. Is that clear? Okay, then at t sub 2, which we know is 4 seconds. We haven't done that one, so we need to go and do. Gain will be equal to, so let's go to our velocity function. And velocity function is what? 3t squared plus 5. So it will be 3 into 4 squared, okay, plus 5. So this implies that your V will be equal to 3 into 4 squared, which is 16, okay, plus 5. So here, let's go. That will give us, do the final one for me. My professors, hurry up. Let's go. You know, these calculations are for you. 42 plus 5. Is that it? Hey, my professors, are you there? Let's finish this one quickly. Our time is almost up. And in fact, we are supposed to end. This will give you what? 18. Okay, so 1. Okay, so you are going to get, so 48. Am I right? 48 plus 5. Hello? Oh, are you there? Let me see those who are here. Oh,
53.
it will be what? 53. Okay, so the 53 that we have there, we are going to, okay, so we know, okay, therefore, okay, don't, if you like, attach your units, okay, here, though you are not concluding, so therefore, AVG, okay, sub AVG will be equal to, okay, we said our second velocity, okay, this is V sub 2, okay, so this will be V sub 1, we have to be careful. We didn't do our representation. Okay, so V sub 2. The other one too, let me see whether I use the V sub 2. S sub 2 I did after writing the implication. So V sub 2 we know is 53. Minus V sub 1, which is 17. Okay, over T sub 2, which is again 4. Minus T sub 1, which is what? 2. Okay, so that gives us, my professors, I'm waiting. 19 over 2. Oh, this one will give us, let me see. So that will give us what? 30.
36.
36 over 2. Okay, which gives us,
18 meters
okay,
per
so
second.
18 meters is acceleration per second squared. Okay, so we are done. Okay, so the others, we are left with the last one, a very important question. I forgot, only that I will just draw your attention to something. Okay, there. Okay, so this is it. E. Okay, so I think I will leave E to you as your assignment. Let me see how you can appreciate the E. So the distance moved in the second. Okay, do it and send it to me. The distance moved in the second. Okay, the distance moved in the second. Please, okay, let me quickly walk you through. Okay, so the distance moved in the second doesn't mean t is equal to 2. Please take note. Okay, if you are starting from, this is your first second, your second. Okay, so the movement here is the distance moved in your first second. The movement here is the distance moved in your second. So the distance moved in your second will be what? Your distance at t. So s at t is equal to 2 minus s at t is equal to 1. Is that clear?
Yes, please.
Okay, so take notes. You know my questions are carefully selected, okay, to bring out all the various traits. Okay, so you substitute, okay, t is equal to 1 to find that t is equal to 2, then find the difference. So that will give you the distance, okay, it moved in the second. Okay, on this note, thank you very much, okay, for your time. At least the lesson, initially, I wasn't too happy about your, okay, response rate, but at least you stayed with me, you stuck with me, okay, throughout up to this point. So God bless us all.